Welcome to this spoken tutorial on the Linux shell. Open a terminal window in Linux. We can see a prompt, that is a $sign, and a cursor blinking next to it. This is where we need to type in a command. Type in the words WHO and press enter. We can see name of the users logged in. Actually, we have just executed a command called who, which shows who are logged into the system. But which entity is converting these commands, which are nothing more than a few letters, into actions? This is the job of the command interpreter, also called the shell. We can define a shell as a program that acts as the interface between us and the Linux system, allowing us to enter commands for the operating system to execute. On Linux, it's quite feasible to have multiple shells installed, with different users able to pick the one they prefer. On Linux, the standard shell is always installed as /bin/sh is called bash, the GNU Bourne Again shell from the GNU suite of tools. Because this is an excellent shell that is always installed on Linux systems, is open source, and is portable to almost all Unix variants, bash is the shell we will be using. Other shells include the Bourne shell, which is the original Unix shell, C shell, and Korn shell. The shell uses a special set of characters to match file names. These are called wildcards. Some of the wildcards that we would look into are star wildcard, character wildcard, and character class. First we see the star wildcard. Say we have to list all the files in the present directory that start with the letters TUT. One way is to type the names of all the files, that is ls space -a space name of all the files starting with the letter TUT. The problem with this is that first all the file names have to be typed, which is cumbersome. Secondly, we have to remember all the file names from beforehand. Instead, we can use the star wildcard. We type ls space -a space TUT followed by a star. We get the same output for so much less work. In fact, star matches any number of characters including none. In fact, if we type echo space star, the names of all the files in the present directory would be displayed. This is because the star matches all the file names. Now we clear the terminal with the clear command. Next is the character wildcard, denoted by a question mark. It in contrast matches a single character. So if we type ls space -a space TUT followed by a question mark, it will display TUT-A, TUT-B and TUT-C, while leaving out TUT, TUT-01, TUT-02, TUT-03. Since after TUT they have 0 or 2 characters and are hence not matched by character wildcard. The only characters that the star and character wildcard cannot match are the / and the dot, when the dot is the beginning of a file name. If the dot comes somewhere in between, then it is matched. For example, if we type ls space /usr/bin, all the files in the /usr/bin would be listed, but we cannot substitute it with ls space /usr ?bin. Now let's clear the terminal with the clear command. Also, since the files starting with dot are not matched with star or character wildcard, when we wrote echo space star, it did not list the files that start with dot. For doing that, we need to type echo space dot followed by a star. The greatest power of the above two wildcards may turn out to be their greatest weakness as well. The fact that they can match any character can be undesirable. Say we only want to print TUTA and TUTB and not TUTC. Neither star nor character wildcard can do that. We need our third type of wildcard, the character class, for that. A character class matches a set of characters that are mentioned within a square bracket, say CVG inside square brackets. This is a character class that would match only the letters C, V and G. So in our case, to list only TUTA and TUTB, we can write ls space -a space TUT followed by AB as the character class. Say we want to match only those file names that end with a number. So in that case, what do? We type ls space -a space star followed by all the numbers in the character class. Though this works, there surely is a better way than this to do it. What if we have to list all files that end with an alphabet? So what do is, we can give a range of characters by mentioning the first and the last character in that range separated by a hyphen. Say for all small letters we can write small a hyphen small z. For capital letters it would be capital A hyphen capital Z, and for any letter it can be capital A hyphen capital Z followed by small a hyphen small z. So in our problem of listing all files that end with a number, we can simply write ls space -a space star followed by the numbers as a range. We may also negate the character class. In this case, all characters except those mentioned within the square brackets are matched. For example, ABC negated in a character class will match all characters except A, B and C. Example, say now we want to list all files except those that end with a digit. We need to type ls space -a space star followed by negating all the numbers. One thing to keep in mind about wildcards is that they are not part of any command. Neither do the commands understand them. They are patterns that the shell can understand, and the shell expands them before executing any command. Sometimes we may not want the wildcards to behave specially. We may want them to behave like any other ordinary character. Like say, we want to make a file named tut star. What can we do? There are two methods to stop the shell from interpreting the wildcards. They are escaping and quoting. In escaping, we provide a backslash before the wildcard to remove the special meaning. Like if we want to actually create a file with file name tut star, we can type cat space greater than symbol space tut followed by a backslash followed by a star. Press enter and we can write something like, this is a demo file named tut star. Here the backslash causes the shell to treat star as any other ordinary character. Escaping can be useful for other uses as well. It can be used to escape a space and the backslash itself. Sometimes there exist files whose names have a space. Say we have a file named my space demo file. Now if we run a command on them, they would be treated as two separate files. Say we type wc space my space demo file. WC will treat it as if two files have been given, my and demo file. To actually get this to work, we need to give a escape the space. Now we type wc space my followed by a backslash to escape the space demo file. We get the required result. The other method of removing wildcard behavior is quoting. Here we can enclose the wildcard or entire pattern within quotes. Anything within quotes is not interpreted specially by the shell. We can use both the single quotes and the double quotes for this purpose. The single quotes protects all characters except the single quotes, while the double quotes protects all the characters except dollar and backquote. So we can have things like rm space tut star under single quotes and rm space my space demo file under double quotes, and they would work perfectly. This brings me to the end of this tutorial. Spoken tutorials are a part of the Talk to a Teacher project supported by the National Mission on Education through ICT, MHRD, Government of India. For more information on the same is available at the following link: http://spokentutorial.org/nmeict-intro. The script for this tutorial has been contributed by Anirban Roy Chaudhary, and this is Ankit Agarwal from IIT Alwar signing off. Thanks for joining.